Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, great write-in suggestion this week. The engineering behind F1 racing
Oh, it was F1 racing.
versus.
I don't know where I was going with that.
I thought you had something clever.
I was trying to be funny and I lost my train of thought.
You were not. See, you should leave the humor to me. Everybody writes in and says that I'm the funny one anyways.
You were definitely the funnier one.
Funny,
show.
Handsome, smart. It's always my mom writing in, but I appreciate it.
I did
you see her comment?
She commented.
I love it.
She should do that with like a different name. Like people know that it's your mom saying best podcast ever.
At least,
go, Jamesy.
At least she wasn't saying that you looked so handsome like she did the last time. That really hurt my feelings. Yeah, it did get awkward too. All right, Luke. Basics of F1. So I kind of want to talk about what F1 is to begin with, because it turns out some of our listeners might not know.
Yeah. So, I mean, we'll get to it a little bit later, but like, I know what it is just from just TV and stuff like that a little bit. I didn't really know until I did my crack research. Last, 47 minutes. But like, there's not a single American driver or American team, like, which is crazy. Well, I think there's an American team, but there's no American drivers, because I think there are some companies in the United States that are actually sponsoring the teams. But it's just crazy that there's not a single driver from the United States.
I think it's pronounced American in F1.
Oh,
but just putting that out there. Or maybe that's just NASCAR. I don't know. Really simple though, right? Cars drive really, really fast. The first car that passes the line wins.
Mm-hmm.
Drivers get points, or I guess their teams get points, right? Mm-hmm. Based off of how they finish. And at the end of the season, if you have the most points, you win.
I think that's pretty straightforward. Yeah. I mean, but then there's all kinds of like nuances. So before we get into like the engineering, could I do a little bit of history?
You can do a lot of history, Luke.
I know you love F1.
I do. It's in my blood.
So this all goes back to the word Grand Prix.
Prix, yes.
Is that how you pronounce it? Prix?
Yes, absolutely.
I'm pretty sure that's what. Oh, Grand Prix. Sorry. So it was the first time that word was ever used was in 1901, and it was the French Grand Prix at Le Mans. And I think everybody has probably heard of that one. It's one of the more famous ones.
For sure I have.
So this was basically individuals taking cars, stripping them down, souping them up, and they would like race from town to town. You know, it was basically road racing. And it was super shady, super dangerous. There were like, people were like going off the track and like doing shortcuts through like, fields, and there was no regulations at all. And
that would be me like running a marathon. I'd be that guy that like cuts across the streets and then comes in like, hey, I finished.
And you like pour water on yourself to pretend you were sweating. Yes. Yeah. So it wasn't soon after the formation of the Fédération Internationale des Automobiles, FIA, F-I-A, was established. It was a nonprofit association established to represent the interests of motoring organizations and the motor car user. I think it's kind of like a AAA-ish. Like when I look at what they do, I thought it was just racing, but like if you go to, it's called the FIA. They always put the word "the" in front of it, which is a little odd.
It's like the Ohio State University.
Exactly.
Bunch of pompous jerks.
Exactly. Yeah. It looks like they do all kinds of like, not just racing stuff. Like it's all about like, automotive safety and mobility and access and all. So I think it's like a European AAA. I think I could be wrong. I don't know.
I'll go with that.
So that was established in 1904, and essentially they basically just started to make rules and regulations, specific safety things, those sorts of things. In 1933, they actually started using a grid to decide how people would start after qualifying times. This was done in the Monaco Grand Prix for the first time in 1933. In 1946, Formula One was agreed as a recognized part of FIA, because I guess it wasn't called F1 or Formula One before then. And then I'm going to jump like way ahead because it gets kind of boring. They started to host these races pretty much all over the world. And the oh my goodness, I just lost it. Oh, I'm sorry. So 1954, they start limiting the engine sizes because people were just building like ridiculous engines.
Yeah.
So in 1954, they started limiting the engine size to 2.5 liters. This was going to make sure that it was a way more competitive. Let me see. Next. 1961, they went on to a 1.5 liter Formula One engine. Probably the most notable thing that happened was it was back in 1994. I'm jumping way ahead. This is a big long timeline. Atron, Ayrton Senna, I just know the last name Senna because there was a movie, was killed in the San Marino Grand Prix a day after Ronald Ratzenberger was also killed in that accident just during qualifying. So this was whenever the safety element of Formula One, it was always safe, but not a single driver has died behind the wheel since 1994. There's been lots of accidents.
But this have a connection to the engine size, or are you just pointing this out?
So no, this is just timeline. Just
okay.
Yeah. So but this does go to the engineering since 1994 of designing,
a lot safer, around safety.
Yeah,
gotcha.
All about safety,
which is apparently working since you said no one's died since then.
Since 1994, I didn't realize that was the year I graduated. The year after I graduated high school, not a single F1 driver has died.
So you would think that would not be the case, right? If you look at like NASCAR, they have those giant pileups. They have people dying. They have, not like every day, right? But like they have deaths, and they drive in one big circle.
Mm-hmm.
And they're not F1 cars going nearly as fast. And F1 cars are all like, like that's the noise it makes when you drive around their
definitely
track.
Blind hills and hairpin turns.
Yeah, so that's really impressive. But I guess, yeah, I don't know. Go ahead.
And then they started to make regulations for so in the 90s they started making regulations on like tire sizes and using really specific tires. Probably the biggest one was whenever they started, this was in the early 2000s, they started to make really specific. It's kind of crazy. It is where was the note I made? The technical regulations for the current build for cars. So this was back in 2017, I think it started, maybe 2015, is a 158-page PDF that you can actually look at. And
Did you open it?
I did. It was like every single aspect of the car is defined and what it can do and what it can be and like how many you're allowed to have, because apparently you just can't keep buying stuff. You just got to fix it. If you run out, then you don't race anymore.
So I thought it was really interesting. Like you're saying, it's this giant document. Everything's super well defined, but not everything. Mm-hmm. And it seems like F1's really cyclical, is what they say, where it's like a team will find one tiny thing that isn't really clearly defined in the rules.
And they exploit it.
They take it a little over the edge. They start winning. Something bad usually happens. And then F1 kind of reins things back in. And it seems like that just keeps happening over and over. Then they're like, okay, what about this little thing that's not completely defined in the rules? And that's the next part that they optimize to get that edge over everyone else. And they're optimizing it in a way that it's, to the tune of like bajillions of dollars for the tiniest little improvements. But that's what sets them apart.
That's all I had on history. That was really quick. There was a whole bunch of stuff in the middle, but this was one of the few episodes, James, where like when I typed in like F1, there was so much. Like,
oh my goodness, yes.
Like in the US, it's not a big thing, but like everywhere else in the world, this is like the biggest motorsport, like by far. And there was just so much info that I had a hard time compiling the info, to be honest with you.
Oh yeah, it is a lot, And yeah, that's that. There were tons of information.
Quick fun facts.
I need some fun facts right
now. There's only 10 teams.
Losers.
Each team has 2 drivers in 2 cars that race at all times. Like, I always wondered why, and I guess in NASCAR they do that too. They're on a team, and there's more than
teams. Yeah.
But it's specifically they have 2 drivers, 2 cars, every single race. So there's only like 20 cars in a race. I mean, it's not a big.
Basically none.
Yeah, I mean,
I do that on 376 every week. Yeah. Fun fact for you, Luke.
Shoot.
It is time for us to take a break for a word from our sponsor.
I'm going to say it's going to be the FIA, because you have to put the word "the" in front of it.
You were wrong. It is the Red Bull Racing Team. No, it isn't. It's no one. It's shout out time.
You like Red Bull?
No. When I was younger, I would, drink it with the shots, and that was never good. But yeah, I don't do Red Bull. I don't need energy drinks, Luke.
Shout-outs are so much better than money anyways.
I hate money so much, but I love shout-outs. Shout-out number 1 for the person who brought this episode back up, Uncle Bill. If you are related to my wife, you get priority on topics. So, nepotism.
Hold on. Was this really Uncle Bill?
This was Uncle Bill that wrote in and said, yo, do F1, James, or you're out of the family. So I was like, well,
that's hardcore.
I don't entirely want that, so let's make it happen. The second shout out, much longer. This is Ashley S, and I found this very entertaining.
Ooh.
I stumbled across your podcast a few weeks ago. Remember that this was back in October, so a few weeks ago,
a few months ago,
when searching Spotify for a rap song that started with engine. I'm not an engineer, but I work at the largest aviation company in the US, I guess we're not naming names, and interact with engineers every day. At the end of the Wacky Units of Measure show, you asked listeners to write in if we missed any good ones. While not totally a unit of measurement, it reminded me of this article that I found a few years back. She sent the article. Basically, there's a calculator to determine how many cows a woman is worth.
Wow.
I went to find this. I read the article. Very interesting. I couldn't find the app itself, but I'm going to keep looking. Finally, one thing I've learned from listening to your podcast is that you're potentially behind on emails. That being said, today is October 3rd, 2022. If you could help wish my friend Andrew a happy birthday for December 23rd, I would greatly appreciate it.
We made it in.
We made it in. I'm super proud of us.
If we publish this before December 23rd.
So I wrote back. I told Ashley that I would request that you produce this one soon. It won't come out on the 23rd, but at least I'm guessing Andrew doesn't listen either, so she can point him to this great happy birthday, Andrew wish.
There we go.
So, very good. Ashley, thanks for writing in. That's great. Luke, how many cows do you think you would be worth?
Me? I don't know. 3, 5, something like that.
So I told her that you would probably between like more than 2, probably 4 at most. So 3, 4, I think we're on the same page.
Yeah.
Okay. We won't get into how many cows I'm worth. If any of you want to write in and tell me how many cows I'm worth, how many you think Luke might be worth, which is surely less than me. If you want to tell us what a great job we do, if you want to suggest some episodes, anything like that, if you want to tell Uncle Bill to stop giving us episode ideas because you hate F1, I don't know. Email us at unprofessionalengineering@gmail.com.
And don't forget to subscribe, like, share. We love the reviews. And as always, you can tell your smart devices to play the Unprofessional Engineering podcast anytime.
Luke, can we actually talk about engineering?
I think we do.
That's what people are here for. They know us as great engineers, and this is...
That noise is me laughing if you don't know what it is, if you're not watching
this
on YouTube.
Muttley?
Yeah.
You sound like him.
I did.
Yeah. Since 2014, Formula One power units have been based on a 1.6 liter V6 direct fuel injected turbo hybrid engine. Luke, I knew that off the top of my head from my intensive work done on F1 cars.
I also know that it has a maximum per minute RPM of 15,000.
Oh, does it?
Top of my head, yeah.
Good, very good.
That's a high RPM. 15,000?
It turns out these are powerful.
Like, my car goes to like 8,000 RPMs. The
I
Tacoma,
don't really know what mine
something
goes
like that.
to.
I think that's what it is, 8,000. I don't think it's supposed to go at 8,000. I think it's supposed to be in like the 3s or 5s, but
Healthy. Keep the center of gravity low as possible. That's a good thing for these. The drivers are actually seated right on the floor of the car. Sounds terribly uncomfortable. They lean back with their feet all stretched out to reach the pedals, almost like you're laying in a hammock. So maybe it's more comfortable than I think. The chassis is made out of super ultra lightweight carbon fiber, and this makes me super uncomfortable. The fuel tank is right behind the head of the driver in the middle of the car. So this minimizes the chance of it being breached in a crash, causing the car to explode in a fiery ball of
I feel like this
death.
is going to be a good sound effect episode.
I'm on top of it. You need to start chipping in.
I'll do my best.
Fun fact for you, Luke.
Shoot.
The cars have 8 gears. I did this, but it's this, plus reverse, with only 2 pedals at their feet, the accelerator and the brake. The fun fact, that's not exciting, I know. The fun fact part, though, is the upshift and the downshift levers and the clutch lever are behind the back of the steering wheel and operated by hand. Have you looked at what that steering wheel looks like?
They're bananas.
It's the most intense gaming controller of all time.
So I saw this picture that was like a timeline of like F1 steering wheels.
Yeah.
And it was like a piece of wood, like early on. And then there was a Ferrari looking steering wheel, which still had nothing but the wheel on it. And then it started adding some buttons, and like the most current one, it's not even a full steering wheel. It looks like it's like Knight Rider. It only has the handle parts on like either side. Like I don't think there's a top to it or a bottom to it. And then there's like a digital display, tons of buttons. And you know why it's like that?
Why is it like that?
Because all of the adjustments that they make while they're racing, the driver themselves, it's in the rules, they have to make. So most of these cars have adaptive suspensions that need to adjust based off of wind and rain and all that sort of stuff. So they can't come in during a pit and have the team adjusted, or the team can adjust it remotely.
Aren't the pit stops like 3 seconds? It's like something really crazy.
Again, watched another video of an old pit stop versus a new pit stop, and they had them like side by side, and it was like boom, boom, 3 seconds, and then it was like the other guy was like having a sandwich while they was waiting for him to fill the gas.
They play like old Charlie Chaplin music as it's going on, like. So the Formula One cars are a little bit fast. They reach speeds at around like 360 kilometers per hour, which is kind of speedy. That's over 220 miles per hour.
But that doesn't happen very often. That's max, because they're doing
the
twisties.
Yeah, the twisties. Yes,
the twisties.
They don't have the zoomies often. They have the twisties. Fun fact for you on the engineering side, the cars contain over 1,000 sensors that monitor everything from like the engine performance as things are going live to the airflow around the car. The data collected by these sensors then help the engineers to optimize the car's performance. Not necessarily this too, like when they're working on it to then send it back out to race again. Oh no, they're using this data to optimize the car while it's racing.
As it's racing.
It is unbelievable. They're equipped with super fancy electronic braking systems that help brake more efficiently. They're fitted with sophisticated traction control, which is really important because if you look at the like hairpin turns, like you were saying, this keeps the cars from spinning out of control around those. Really sophisticated aerodynamics. That's kind of what this all comes down to, right? They get through the air real efficiently, and they have really high-tech suspension systems, which we'll talk about a little bit more in more detail also. You look like you have something to add.
Yeah, I want to talk about engines for a minute.
Okay.
That's okay. So the 2022 engines produce over 1,000 bhp. And I was like, BHPs. What is bhp? I was like, I know what HP is, horsepower. So
big Herzing power.
No, I knew you were going to ask. So bhp stands for brake horsepower.
Oh, who knew?
And here's the difference. The difference between the two is the relationship to the measurement. bhp is the measurement of the actual horsepower of the car at the wheels. So like they take into account the entire system to measure the horsepower, where horsepower is the amount of horsepower that exists at the engine. And the weird thing is, I might be saying that completely backwards because I found like 3 different sites where I looked this up, and one said, oh, BHP is at the flywheel and horsepower is at the wheel. And then I went to another site and it said literally the exact opposite. So it's one or the other. It's horsepower at the flywheel directly off of the engine, or it's the horsepower at the wheel, brake horsepower.
That feels like something I just wouldn't have mentioned, Luke.
Well, no, I think it's good to know what it is, what it stands for. A couple more things on the engines. So there's only a handful of companies that make the engine. So Mercedes-Benz makes them. So the Benz team uses their engine, and the McLaren team and the Williams team and the Aston Martin team all use Mercedes engines. Ferrari makes the engines, so their team uses it. Alfa Romeo and Haas makes it. Haas uses their engine, so Haas, the big machine tool manufacturer. Honda.
Wasn't Ferrari like the engine for a long time?
Yeah, it was. So Honda does, even though Honda isn't in Formula One anymore. They dropped out a few years ago because they're focusing on more fuel efficient and less polluting.
Are these vehicles not fuel efficient?
Not at all. But they do still supply engines to the Red Bull team and to the Alfa Tauri team, Tauri.
I think you got it.
And then Renault. And when I think of Renault, I think the Renault team, a friend of mine had one back in the day, and it was the cheapest, worst car ever. So I like the fact that they make an F1 engine and only the factory team uses it, and they're called Factory Alpine.
Oh, how about that? One fun fact before we take another break. This is kind of related. I just thought it was interesting. Cars lose up to 50% of the downforce when they're racing really closely behind another car, and that's because of all the turbulence of the wake that's generated by the wings and the bodywork of the other car. So this means that it's dangerous for the other cars that are trailing closely behind. So they're much more likely to slide or lose their grip. Now, there's a lot of things that we're going to talk about here on the end of our show, like active suspension, that helps accommodate for that. But again, like you were saying, they started making all of these safety regulations and put all of these constraints on. It's because of things like this that it had to happen. Now, before we get into these safety things, these big tech revolutions, how they come up with all of this stuff, it's time to take a break for this week's Luke's Rant.
So this is directly related to racing, and we talked about NASCAR, and it's just like
the worst.
I don't want to pick on NASCAR, but I kind of have to, because I've watched a little bit of F1, but just the stuff that I did for the research of this episode, F1 is so much more interesting than NASCAR. I've watched YouTube video clips of passing and accelerating and the hairpin turns and the cockpit views, and it is so much better. NASCAR, is it a left that they're always making? I guess it depends. So. Yeah. All they do is how hard is it? And then, did you see that thing on the race? It was a couple weeks ago. This one driver for NASCAR needed to just qualify, didn't need to win, needed to get top 10 to get a couple points, and he floored it and just rode the car along the wall on the outside and was passing people.
Yeah, was that the Joe Gibbs racing team?
I forget who it was.
Just died,
but it was. But they're gonna have to change the rules in NASCAR because he was passing people, riding the vehicle along the wall, flooring it, stuff flying everywhere, just because he needed to get the points. And it's just the fact that you don't even have to steer in NASCAR anymore to pass people. You could just ride the wall. It's like track racing then. Remember as a little kid, the little tracks you would do where you just pulled a trigger, you didn't steer?
I like those.
But it is just the most boringest. I don't know how people get into it. It's like basketball. You watch the last lap, and that's all you need. Basketball, you need the last 2 minutes of a basketball game.
I thought you were saying there were laps in basketball. I was like, you do not know how that sport works.
I don't need to watch I don't need to watch a whole basketball game. I watch the last 2 minutes. I don't need to watch a NASCAR other than the last lap.
How about this, Luke? I think I have it perfect for everyone listening. NASCAR is like the civil engineering of sports.
It is exactly the civil engineering. It's the worst.
It's the worst. Yeah. Well, thank you for that, Luke. I totally agree. So I want to get into the big tech revolutions of F1 over the years.
That's all I've been waiting for.
First, I want to talk about software real quick. Like, how do you make all of these changes? How do you optimize your designs? Computer software. Yay. So software they use a lot of CAD, they use a lot of CAM. So that's computer aided drafting or computer aided design. CAM, what is that? Computer aided manufacturing or machining. Simulate the efficiency. But most importantly, I dare say, is CFD or computational fluid dynamics. I think we have an episode on the basics of CFD if you want to go test that out.
I also know a little bit about it.
You know very little bit about that.
Bit of an expert if I do say so myself.
So products from like Autodesk, Dassault, Siemens are all used. Even some niche ones kind of like SimScale are also used. So, you know, if you want to learn more about those, go check out their great websites that Luke probably made. But also it's kind of funny that they're using this super high-end stuff. CFD is really advanced technology. It's basically like putting a wind tunnel on your computer. So I think I just broke it down in a second.
You did.
But just recently, they got away from some really old technology. One of the teams that I was looking at just got away from using 77,000 lines in an Excel spreadsheet to track and design and build over the season. Like, how crazy is that? So now they're using things like Power BI, which is like a data visualization tool. We actually use that for our marketing stuff and our data, but they use that for better visualization of their data. That's all I really wanted to say about software because I like CFD.
And I just want to do a real quick thing on the monies. I want to make sure we have time before we get to the tech. So this is crazy. So the number one paid driver in the world is a cat by the name of Lewis Hamilton. He's not even the best driver. So he makes 40 million US. The number one driver by far, if you look at the point standing right now, is a cat by the name of Max Verstappen.
Max
Verstappen. He's on the Red Bull team. He makes like half almost. He makes $25 million. And this doesn't include like sponsorships and stuff like that. But he made like, so Lewis Hamilton is the one you see on all the commercials. He's like the most famous, you know.
He's like the me.
Exactly.
F1,
but like the second one make like almost half. And then, so here's Lewis Hamilton. He's on the Mercedes team making 40 million. His teammate are on the Mercedes team. Hold on. He's not even in the top 10.
Wow. What a bum.
No. So he makes less than $8 million a year as his
How does he afford
teammate.
To live?
So Max, who makes $25 million a year, number one driver in the world, his teammate makes $8 million. Which is crazy. Like, so apparently, like, this is one of those things, like, when you're good, you get paid really well. Finally, talking about money, what's it take to build a car? Front wing is about front wing is about $150,000. The halo, the piece that protects the driver, it goes over their head, $17,000. One set of tires is about $2,700. The steering wheel, $50K for a steering wheel.
That doesn't surprise me at all.
The engine unit, $10.5 million. Fuel tank is about $140,000. The chassis varies, but upwards of $700,000. Hydraulics, $170K. Gearbox, $4,000. $40,000. The rear wing, $85,000. So if you had to build a car conservatively, $12.2 million. Just for,
and it's also custom. I mean,
every bit of it.
Well, that's affordable. I saw somewhere, and they probably have it in my technology notes here. The engines only are used. Oh, it's in my fun facts. I bet they're only used for 5 races. Not only is it like the wear and tear on them, but the safety concerns again. They've actually capped it at that. So you're just dumping money into these teams and these cars.
I saw a quote that said the easiest way to become a millionaire in F1 is to start out as a billionaire because the team owners, they just bleed money.
That's really good.
Yeah.
Oh my goodness. All right. So biggest tech revolutions that I picked by hand, stolen straight from a great F1 video. Go to their YouTube channel. Really good. The first one that I saw was curves. KERS, kinetic energy recovery system. This is super neat. We mentioned this, I think we mentioned this earlier, but basically it takes the heat generated when it's braking, when the car's hitting their brakes, and it converts that into energy that's then stored in a battery, kind of like a Prius, but like cool. So no offense, Mom, if you're listening, you know.
She drives a Prius.
Yeah. Okay. But to use this energy, the driver actually presses one of the 472,000 buttons on the steering wheel, and pew, they get this power boost for up to like 6.6 seconds that just shoots this thing out. This came out back in like 2009, really changed.
I remember it in video games, everybody talking about you could save it for using it when you wanted in the video game.
Yeah. Another, we mentioned it a few times, the active suspension. So this kicked in like 1980. It took a bunch of years for it to become more of a thing. But basically, as the cars would drive, they'd bounce around all over on the little inconsistencies and bumps around the track. Did you just hear my cat fall, by the way? That was funny. But this would bounce all over because of all of this downforce that was generated. So to solve this, they used like a computer controlled hydraulic system that was like super fast, that could adjust and keep the car at the perfect height as it drove around the track. It sounds like this technology actually got banned in 93, but it was super cool. I think it might be back again. I'm not quite certain, but yeah, pretty cool there.
I got one.
Yeah, hit me.
This one goes way back. And this is like a lot of cars nowadays. So Renault debuted the dual or double overhead camshaft in 1912 at the French Grand Prix. And pretty much, I think, of almost every car nowadays is that. And if you don't know what that is, simply put, the camshaft is responsible for operating the intake and exhaust valves that bring in fresh air and expel exhaust gas. That's essentially what it does. So apparently that didn't exist before 1912. And do you call it Renault? It looks like Renault, Renault.
But isn't it like a dirty Frenchy team or something? I don't know.
There goes our French audience.
Oh no, 7 listeners. Next one I have is the monocoque chassis, or I mean, if you're going to say it the way it looks, the chases. So way back in 1962, this is basically a single shell. It's way lighter, it's way stiffer, it's way better, and everyone uses that now. Turbochargers, I think this is kind of known. They reuse heat energy from the exhaust and force air into the engine, creating more power. Banned back in 1989, too much power, but they returned in 2014. Ground effects, I think this was cool. By shaping the floor properly or optimized, you can accelerate the air that's going under your car, which creates low pressure. It sucks then the car to the track and gives you better grip. So then you can tail those other cars in front of you a little bit better, with no impact on the aerodynamics. Again, rule makers were like, this is too good and it's not safe. So that got banned, but it's back again in 2022. So big changes this year.
I got one.
Yep.
Paddle shifters.
Yeah, paddle shifters.
So paddle shifters. So apparently, I said this thing where they were invented back at the start of the 19th century, but it wasn't until 1989 that
19th century.
That's what it didn't give a date. It just said 19th century. 20th
I don't know. Century.
Okay, no, it says 19th. It says at the start of the 19th century. It said it wasn't until 1989. F1 season, Ferrari felt that they could add this to a semi-automatic gearbox, and that's because, to your point, there isn't a clutch. Like right. They're not. There's a brake and there's a gas pedal. There isn't a clutch there. So when they're paddle shifting, it's just.
That's exactly what it sounds like.
No, it's too. Like. Is that better?
Who's the guy on?
The guy from Police Academy does all the sound effects. No, not was that his name? Hightower?
I don't remember.
Yeah, he's
Police Academy. Yeah. Jimbo, if you're listening, let me know. Wings, not necessarily like they're gonna fly like an aeroplane, but kind of the opposite. They slapped a wing on the front of a car, and that changed the game forever, Luke. They actually used the idea of an airplane wing. But instead of using this wing to create lift and take off and fly very quickly somewhere else, they flipped that thing around, and now it pushes the car down again for better grip. due to the ground force. This got pushed too far, like everything else, because that's how people are, became a safety concern. It's very regulated now. Fun fact for our true nerds here, there's actually something called an X-Wing. How great is that, right? Yeah. And then the last one that I have listed here is carbon fiber, just in general, right? We have a whole episode on carbon fiber and how great it is, how it's made, all that. So go check that out. But it's super light, it's super strong, it's pretty malleable when you're working with it. It came out in 1981 and everyone spanked the competition when they were using it. So that was that. That's the end of my techs, but I do have some fun facts. Anything else for you?
I do have one more fun fact. So F1 teams started putting diamond coating on the inside of their cylinders to reduce friction. And then you mentioned the hybrid powertrain. So there's actually two of them. One is the MGUK, which is the motor generator unit kinetic. This recovers kinetic energy from braking. And then there is an MGUH, which is the motor generator unit heat. So they actually have two different hybrid powertrain options that they can access whenever they're doing it. And it says that that recovery, that kinetic braking you talked about, the ERS, it can provide 120 kilowatts of power from around 30 seconds of a lap.
Pretty good. A few more for you. If you guys really love F1, there's a show on Netflix called Drive to Survive. It's supposed to be outstanding.
Okay.
I'm probably not going to watch it. I'm going to be honest.
I'll watch one episode.
All of you should. F1, what's it mean? The F stands for formula, which is the set of rules that the participants have to comply by. And the number 1 is actually naming this as like the highest classification of formula racing tournaments. Average F1 car can accelerate 0 to 100 in just 4 measly seconds.
That's pretty quick.
Fast.
Not as fast as the Tacoma, but pretty good.
Yeah. Engineers not as fast as the Tacoma. Yeah, you're right. Engineers assemble 80,000 components for one car. Feels like a lot. This is fun. The heat that is given off from all these things mean that the F1 drivers lose a lot of weight while they race. In a single match, they'll lose 4 kilograms of weight. So that's almost 9 pounds that they lose. That is a great diet. Formula 1 car tires also lose weight. They lose half of a kilogram in just one race. Probably not good for multiple uses. They have the most advanced engines, so they can only be used for 5 races, like I said. Experts actually claim that F1 cars could be driven upside down if they were given the chance because of how great their components are and how powerful and aerodynamic they are. And then my very last fun fact, it was in 1958 when the first woman held the steering wheel of an F1 car during a race, Maria Teresa de Felippis. So there's that.
I don't think I have any other ones. The only thing that I thought was interesting was they have like monitors that like they have like referees that watch these things, and apparently all racing does. But like when you mess up, like if you like cut somebody off or like do whatever, you actually have what's called a drive-through penalty, where they make you slow down and drive through pit road whenever you mess up. So rather than just like, not letting you win or ejecting you, you just have to like lose, position in the race. And I thought that was, I don't know if NASCAR has that. It might have it. I just thought that was neat.
Very random. This is like a European thing. It's kind of like penalty time in soccer where they're like, yeah, there were a handful of penalties, so we're going to slap 2 minutes on at the end of the game, but there's no real structure behind it. I don't know. Anyways, hopefully you all learned something about F1 racing. I know that I did. Hopefully Uncle Bill's happy with the recap that we did, or else he'll sass me. If you have any feedback on the episode, something cool that we missed, if you want to explain what way whatever Luke was talking about works one way or the other, go ahead and email us at unprofessionalengineering@gmail.com. And until next time,
see ya.